Hello and welcome back to section 15. In this video we'll be looking at example 2. We'll be also introducing the notation that we use to delay when functions turn on and also when functions turn off. Alright, so you can see our example here. We want to write a signal function, I of t. Given that I of t is 0 for t less than 2, 12 amps between 2 and 3, and then back off when it gets greater than 3. So let's walk through this. So what do we know about example 2? So we can write our piecewise function like this. 0, 12, and 0. So this is when we have time less than 2. And then between 2 and 3 seconds, we're at 12 amps. And then when time is greater than 3, we're back off again. So we expect this to look something like if I had t and we have 0. So we're going to actually turn this on at 2. We're going to hop up here. We're going to come over, come back down, and go over. So let me do it with a highlighter so we can see when it's 0. So will be 0 up to 12 for a second and then back down. And so this will be 12 amps up here, and this will be 3 seconds right here. Alright, so that's what it looks like. How do we write that using those singularity functions that we looked at previously? So before, if we thought about our step function, so we would have turned this thing on at 0. That would be pretty easy. We did that in the last example. So how do we delay when things turn on? So we have our step function and it turns on, but we want this now to turn on at 2. So this we write as u of t. And then we can put some constant. Actually, for simplicity, let's just make this k at 12, since that's what we're working with. Alright, so we have 12 u of t. That's what we had last time. But I could also write this as 12 u of t minus 0. Nothing will change when I get to 0. So when it's at 0, we get 0 minus 0, which is 0, which means that it'll be equal to 12, or right after it'll be equal to 12. So the pattern, if you haven't picked up on it, whenever the inside of the parentheses here, so this stuff, whenever this is greater than 0, and for practical purposes greater than or equal to, but whenever it's greater than 0, it is on. Whenever it is less than 0, it is off. So when we're at 0, then it's just whatever the number is. But if I wanted to delay it, say, to 2, well, then I could say, oh, well, 12u of t minus 2. So now if I put in 1 second, so say at 1 second, I would get 12u 1 minus 2. That would be 12u of a negative 1. You can't see that. So that negative 1 means we're going to be off. So this would be how we would turn it on at 2 seconds. So the generic form is something like ku t minus a, where k is the constant we put up here last time. So we can turn it on that way, but how do we turn it back off? So let's look at turning it off. So let's start with the easy way. Let's look at it at 0. It turns off. So let's say it's 12 amps up here, and we want to turn it off at 0. We're just going to end up doing a 1 minus. So if I do 1 minus the quantity 12 u of t, well, that won't work. I actually have to put 12 here. So you put 12 minus 12 u of t. So it wants to naturally be at 12. So we'll put that in this blue color here. So it wants to be up here at 12. And then what happens when we get to time equals 0 is we're going to subtract 12. So when I get to time equals 0, we subtract our 12 and we go back down. And so the curve itself becomes this one. And then the upper part goes away. So what if we wanted to turn it off at 2 seconds or 3 seconds, like our problem? So instead of 0, we're going to turn it off at 3. So we're going to pretend that it's on for right now. So it starts off, it's on at 12, and then it's going to turn off. So we're going to subtract 12 when we get to 3 seconds. So that would be our function. So it's a constant 12, but when I get to 3 seconds, I'm going to subtract 12. That's what this says. So let's go back up and answer our problem. So how we do this? So we start at off. So if you wanted to, you could say that, oh, well, I of t is equal to 0. So we're initially at 0. Then we're going to jump up to 12. We're going to use a step function just to demonstrate that jump. And it's going to be t, but now we're going to do t minus 2 because it's 2 seconds later. And so now, if I evaluate this whole thing, I'm at 12. So I'm up here at 12, and I want to turn it off. So we're not going to say plus 12 minus because we're already at 12. So then we're just going to subtract 12 when we get to 3 seconds. So u t minus 3. So that is your answer. I'm sorry about the freezing on the screen. I don't know why that keeps happening. If you have any questions, feel free to contact me.